Hi, this is Leetcode weekly contest 317. Let's start with the first question. Average value of even numbers that are divisible by 3. Given an integer array nums of positive integers, return the average value of all even integers that are divisible by 3. Note that the average of n elements is the sum of the n elements divided by n and rounded down to the nearest integer. Example nums 1, 3, 6, 10, 12, 15. 6 and 12 are even numbers that are divisible by 3. 6 plus 12 divided by 2 equal 9. So this is a simple question. What we need to do is to loop over all the value and check for each value if it's if the value or number modded to equal 0, so that we know if it's even. Then we need to check if mod 3 equal to 0 for this condition. If the condition meets, we need to increase the count, and at the end also beside the count we need to accumulate the sum, and at the end if the count is 0 there is no numbers meets the condition, so we return 0. Otherwise we return the sum divided by the count, which represent the average. Alright, let's see the second question. You are given most popular video creator. You are given two string arrays, creators and IDs, and an integer array views, all of length n. The ith video on platform was created by creator y, has an ID of IDs y, and has views of I views. The popularity of creator is the sum of the number of views on all the creator videos. Find the creator with the highest popularity in the IDs of their most viewed video. If multiple creators have the highest popularity, find all of them. If multiple videos have the highest view count for creator, find the lexicographically smallest ID. Return a 2D array of strings answer, where answer by creator ID and ID means that creator I has the highest popularity and ID is the ID of their most popular video. The answer can be returned in any order. So assume we have this array for creator and these IDs, and these are views. We need to find all the creators with the maximum number of views. So for Alice we have ID 1, and so view, and the number of views is 5, and we have also for Alice the ID video 3 with number of views 5, so he has 10 views. And we have Bob with video index 2 with number of views 10. So first of all we need to find the number of views for every creator and determine what is the maximum. In this case the maximum is 10 views, 10 from here, and there is 5 plus 5 and equal 10. So for Alice it's 10 views, for Bob 10 views, so we need both creators. Then we need to for each creator return the ID of the video, the ID of the video that has the highest views. For example, for Alice we have video 1, video 3, and both have views 5, so we need in this case to return the lexicographically smallest ID. In this case 1 is less than 3, because O is less than T. Since 1 is less than smaller than T, it's included in the answer. For Bob we have 10 views as we said it, which is the maximum, and the video, there is only one video, which is 2. So the final result will be this one. Alright, here are the constraints: unequal, less than to or equal to 10 to the power 5. Views of I also less than or equal to 10 to the power 5. Creator I and IDs of I consist only of lowercase English letters. Alright, first of all we need to define a map that match each creator with how many views. So we need to loop over these arrays, and for every creator we need to accumulate the number of views related to it. Then we need also a dictionary for creators with IDs map. So for every creator we need to have a set of pair. The first item of the pair will represent the number of views, and the second item of the pair represents the ID of the movie or the video. And remember that the set is sorted in non-decreasing order. This is the set, and so here in order to have the proper sorting, we need to push this value as a minus value, in order that the first item of the set will be the smallest, but it has the highest number of view. This is why we have to push it here as minus. So we loop over all the values. Then for every creator we increase the number of views, and here we define the max views among all the creators. So max views equal max of max view, and this value. And also we need to assign the creator the creator set to this pair, which include the views plus and comma the IDs of I. And we need to loop over the creator views map. Now we know the max views. Every creator has views of equal to the max. We need to push it to our result. So result push the creator who has views equal to max view plus the first element in the set, because the first element represents the maximum ID, or the maximum ID which has the maximum view, or it represents the ID that has the maximum view. So, and remember we need to push only the ID. So here result it contains the vector of string. Each vector of strings has two items, creator and the ID that has the highest number of views. Alright, let's see the third question. Minimum addition to make integer beautiful. You are given two positive integers n and target. An integer is considered beautiful if the sum of its digit is less than or equal to target. Return the minimum non-negative integer x such that n plus x is beautiful. The input will be generated such that it is always possible to make n beautiful. So assume we have n equals 16, target equals 6, output equals 4. Y initially n is 16 and its digit sum is 1 plus 6 equals 7. After adding 4, n becomes 20 and the digit sum becomes 2 plus 0 equal 2, and it can be shown that we cannot make n beautiful with adding non-negative integer less than 4. Here n become beautiful because 2 is less than or equal to the target. Here we have the constraints. N is less or equal to 10 to the power 12. Target is less than or equal to 150. Alright, to implement this algorithm, assume we have some number and this number has digits 6, 7, 4, something, and this represent n, this number, and we have target value, say 57. So first of all we need to do the summation of this for all the digits in n, 6 plus 7 plus 4 plus whatever, and check if the summation is less than 57. If it's greater, we need to find the minimum number that we add to n so that the summation of the digits become less than or equal to 57. So if you noticed here, if we add the value 1 to this digit, or 2 or 3, it will not make any sense. It's just make the summation of the digits larger, because whatever the summation of the digit plus 1 plus or plus 2 plus 3 still it will be larger. So in order to find which x, first of all we need to for each digit, let's say we start with the last one, 6. The only possibility, if this number is a summation of all digits greater than 57, we need to check for adding 4, because 4 plus 6 equals 0, and the first digit will be 0 in the new n, and so it's possible that the new number summation of all the digits become less. Then if it did not work, then so our first number is 4, then we need to go to the second one, 4 plus 6 equal 10, so 0, this number become 8. Then for 8 we need to try 2, then 2 plus 8 equals 0, and here 4 become 5. For 5 we need to try 5. If it's still the number is greater than 57, we need to check for all the digits. So this is the algorithm. This is helper function that takes a number and return the summation for all its digits. So simply it converts the number to a string, and we loop over all the string and to accumulate the summation. And initially we calculate the summation for all the digits for the number n, and we keep looping until the sum as long as the sum greater than the target. What we will do, we convert the n to a string. Then, as we said, we need to move digit by digit. We start with the last digit and we check what is the number, which is 10 to minus the last digit value. This is d, and this d we need to multiply it by the index of this digit. For example, if it's here d equal 4, then the value of this is 40. This is why here we multiply by power 10 comma I. Then we need to increase the I for the next iteration. Then we need to add this new d to n, and then x plus equal d. X will store our result. Remember, for example, for the first digit, if we have 4, the second digit we have 2, so this is our final x. So we need to keep repeating this until the sum become less than or equal to target. Let's see the last question. Height of binary tree after subtree removal queries. You are given the root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array queries of size m. You have to perform m independent queries on the tree, where in the ith query you do the following. Remove the subtree rooted at the node with the value queries of I from the tree. It is guaranteed that query of I will not be equal to the value of the root. Return an array answer of size m, where answer of I is the height of the tree after performing the ith query. The queries are independent, so the tree returns to its initial state after each query. The height of tree is the number of edges in the longest simple path from the root to some node in the tree. So for example, if we have this tree in the left side and the queries contains the number 4, so it means that we need to remove this subtree 4, and the tree become like this 1 3 2, and the height of this tree is 1 2, so the result will be 2. For this tree, the first query is 3, so if we remove this node 3, the height of the whole subtree will the height of the tree will be the longest one, which is 1 2 3. And the second query is 2. Remember, after we query the first one, like after we delete 3, we return it back, so the tree return back to its original state. Now we need to delete the node 2. The node 2 is here. After deleting this node, the height of the tree become 1 2. Then after removing 4, the height of the tree is 1 2 3, so we have the answer here is 3. And 8, we remove 8, so the whole left subtree is removed, and the height of the tree remains 1 2. So in order to solve this, first of all, we cannot for each item query go and delete the node and check for the height, because the time complexity will be big of n, which is the number of nodes, multiply by the number of queries, and it's too much. You can see here the number of nodes is 10 to the power 5, and the number of queries is 10 to the power 4, so you cannot do 10 to the power 5 multiplied by 10 to the power 4. This is 10 to the power 9. We need a smarter solution. So to solve this problem, first of all we need to traverse the tree, and in a dictionary we need to store the height of each node in the tree. So for example, for 5 we will store 1 2 3 the height. For 8 we will store 1 2 the height of this subtree rooted at 8. Then for 2 the height of the tree rooted at 2 is 1. For 9 it's 1. For 3 it's 0. For 7 it's 0. For 1 it's 0. 6 0 4 0. So first of all we need to store the height of each node in the dictionary, as we said. Then we need to we need to visit each level of the tree. So level 0 is 5, level 1 is 8 9, and level 2 is 2 1 3 7, and the last level is 4 6. Using Q, or breadth first algorithm, we can traverse each level, and for each level we will store all the nodes on this level, and along with the height for each node, and we sort these nodes based on their height. Then after we store every level nodes, we need to traverse each level, and for each level we check if the nodes exist in the query. If it exists on the queries array, it means that we have to store the result for this node, and because we know which nodes are in this level, so we can pick the node that has the maximum value after removing the query node. So for example, let's take this as an example. So as we said, for every node we store the height. So we have dictionary that has 5 with its height, which is 3, 8 with the height 2, 9 with the height 1, and so on. And let's see, so first we traverse the first level. The first level has node 5. Node 5 does not exist here, so we move to the next level. Next level we have two nodes, 8 9. The first node is 8, but 8 has the height 2, and 9 has the value 1, so we will store 9 or 1, which is the height with 9, then 2, 8. So we sorted based on the height, and we said 9, this node does not exist, but 8, it exists on the queries. So what we need to do is we need to check if there is greater node with greater elements. If not, we need to check the next after deleting this node, what is the maximum value, what is the node that has the maximum height. In this case it's 9. So 9 has height equal to 1, so we know we are at level 1. So the result will be 1 plus the height of 9, which is equal 1, equal 2, and we store it for the value 8. And if 9 it's in our queries, 9 is the first element. So imagine if we need to delete it, so we check so this node is not the last element. It means there is an item that is has the greatest height, which is 8, and its height is 2, and again we know we are at level 1, so 1 plus 2 equal 3. So we store for the 9, we store the value equal to 3. Now imagine if we have the nodes with this shape, and we are at this level. Now our set will contains only one node, so what to do in this case? Well, there is no other nodes that has the maximum value. In this case we need to calculate, after deleting this, the height of the tree will be the height of the root node here minus the height of this node that we are deleting. So let's see the algorithm. First of all, we have this map, which maps the integer to a vector of integer. This is query indexes, so we loop over all the queries and we store for every query which indexes this value has in the queries, so that later on we can use these queries to check if some query exists or not. It's a constant time to check if there is a query with a specific value, and if there is a query with a specific value, we need to know which index is for this query. Then we need this height map. Height map will map every node with its height, so we need to calculate the height for every node using get height function. Get height function takes the root initially and the height map, and it's simple function. It's calculate the left height, the right height, and the current height will be the maximum of both, and we store the height of the current node into the height map dictionary. After that, we said we need to traverse every level to store to store all the nodes beside their heights. So the level nodes, it's dictionary that maps a node to or sorry, it maps the level number 0, 1, 2, 3 to all the nodes in that level. And the nodes, we don't only store the node, we store the node with its height. And so this is simply breadth first algorithm. Using Q we can traverse every level, and for every level we push back all the nodes as a pairs. The first item in the pair is the height of that node, then the node value, and here we have the final result or the vector that will store the final results for queries. And here we need to loop over the level nodes map, the one that we calculated here using the breadth first, and we loop over the map using, so we have level and we have nodes pair. Then we sort these nodes based on their height from smaller to the largest, so that we know if we want to delete the first element, we have the good candidate will be the last element which has the highest height. For auto node pair on the nodes, so we loop over all the nodes in this level. The node value will be the node pair, the second item in the pair, and we need to check if there is a query that has the value of this node. If yes, we need to calculate the height after the deletion. And as we said, if there are too many nodes or if there are more than one node in this level, then we need to check if the node if the current node equal to the last node in the array which has the highest value. If yes, then we need to take the second highest value in this level, which is the last one, or the node dot size -2. If it's not the last value, or if it's not the node that has the highest height, then it means that we are deleting a node. We are deleting a node that's not the highest. For example, in this level we are deleting 9, and so the height on this level will be for the value store at 8. So here height equal the last value, and plus we need to add the level. So here we have the height of this node, the height of the tree equal to the height of this node, plus which level. Here it's level 1, here it's level 2. Now here, if the nodes are greater than 1, if there is only one node, as we mentioned here, we need to calculate the height in a different way. The height equal the height of the root minus the current height for or the height for the current node -1. And for all the query indexes that has the value of this query, so maybe we have queries with duplicate values, so the height will be the result of all of these queries, and we store the height into the correct index using the query indexes map we created at the beginning. The time complexity for this is first of all to get the height for every node. So assume the number of nodes is n and the number of queries is q. So get height takes big of n, and this spread first algorithm takes also big of n, because we are traversing each node in the level of the tree, each level on the tree. Then here we traverse all the levels again. And for every level we do sort, so this is log, and also we are looping over the queries as q. So this is our final. This is this in from here to n, which equal to, this is our final time complexity.